Hello, students. In this chapter, we will be studying light and how it affects us and how it impacts our daily life. But before we begin on studying light, we need to go over a small review about the physical forces that act around us. Our contents for today's chapter will be a quick recap of the work that we've done before. Like I said, we will be studying physical forces once again, just so we can have a small understanding of physical forces before we go into understanding light itself. Then we will study what light is actually, what are the properties of light, and how shadows are formed. So basically, that is what we will be doing in this video today. Now, to recap, what is sound? I hope all of you remember what sound is and that it is a form of energy. Sound works by transporting energy from one molecule to another. Now, if you look here, I've displayed a kind of speaker and there is an ear over here. If you guys remember the lectures that we had in class, you must remember that sound travels by passing energy from one molecule to another and then slowly transporting these energy or this kind of energy from like a source of molecules moving here and there in the form of a wave into the ear that later displays over here that is later displayed over here. Now energy moves from one location to another and at the end of it we can hear the sound waves. Now light is slightly similar to sound, and while it does not work in the same way, light is also a form of energy. Now, if you look at this image here, we know that light travels in packets. Look at these small packets of light over here. I want you to ignore everything else that's been displayed here. Leave that. And simply look at just these packets of light. Now, these packets of light are traveling in a straight line and they're traveling in the same direction. These packets are actually carrying energy and they're known as photons. So always remember that light travels one in a straight line, and number two, light travels in the form of energy packets. Now, if you look here, let's have a quick recap of what we've just studied. Now, light is a form of energy, just like sound and electricity. You've studied sound before, so I want you to be able to relate light as a form of energy with sound as well. We've studied many properties of light in our previous chapters that we've done before in our previous classes. And the most important property of light that you've studied before is that it travels in a straight line. Now, before we move on and we study other properties of light, you need to understand that the earth, it gets all of its energy from the sun. And I'm sure that all of you already understand this. And you've studied this in the chapters in which we discuss the processes of our body. Now, the most important thing here is that sun is the source of light and energy for everything on the earth. So basically, all of these packets of energy that are being transferred from the sun to the earth are carrying the energy that we use for our everyday life, and it is the energy that is consumed in our body as well and in the processes that we do every day. Now, also, you know that light travels in the form of packets and that these packets carry energy, and these packets are how the sun gives our earth its energy. So, um, an important recap: light travels in a straight line, number one. Number two, sun is the source of light and energy for everything on the earth, and that light travels in the form of packets. Now, these are the three things that you guys need to remember. Moving on, if you can see here, I've displayed an image for you, and it really shows a window of and how like light is traveling in a straight line out of that window. And this is a phenomena that we can observe on a daily basis as well. If you look at the windows around you, you'll see that light travels in a straight line from inside of them as well. And you can see this easily, like in the morning when you wake up, if you open a slit um, of your curtain, you can see that light comes in a straight line. A beam of light comes into your room, and this is really interesting because the property of light traveling in a straight line, it really impacts how we view light and how the different phenomena occur around us. So an important phenomena that occurs because light travels in a straight line is the formation of shadows. Now, shadows are formed because light, it hits an opaque object and it can't travel any further, so it creates a shadow behind it. Now, how are shadows formed exactly? We'll see that in the slide that is to come. But let's have a readout of this slide. So, a lot of interesting things happen around us because light travels in a straight line. We've just studied that. If you can see, light is traveling in a straight line over here. Shadows are formed because light travels in a straight line. I just told you that one of the most interesting things that happen because light travels in a straight line is the formation of shadows. Now, this image is showing us a phenomena that we've all seen and experienced. We just discussed this. Let's move on. Now, we were just discussing, I was telling you that we have different kinds of objects through which light can travel or can't. Over here, I've displayed a transparent object in which all light passes through. right down here, we have a translucent object through which some light passes through. And over here, we have an opaque object through which no light passes through at all. Now, shadows are formed when light is unable to pass through an opaque object. If you look at this circular metallic figure here, you can see that it's opaque and light is unable to pass through it. And the really interesting phenomena is that it's displayed, the shadow that is being formed here is of exactly the same shape as the object is right around here. Now, the interesting phenomena is that light is being blocked only in the places where the object is opaque. The rest of the image is being displayed as the same that it is. So you can say that light travels in a straight line, and hence, because it does, it forms such amazing shadows. Now, let's have a quick readout of the slide over here. Now, shadows are an excellent example of light traveling in a straight line. We just discussed what opaque, translucent, and transparent objects are. If you don't remember, it would really be better if you went over the definitions once again and had a quick recall of everything. These will be important later in your papers to come. Now, because light travels in a straight line, when it hits an opaque object, it forms a shadow that looks exactly like the object. And you can see it over here in this image that I've made for you. The shadow, it looks exactly like the object over here. The circular object is exactly like the shadow. However, a shadow changes according to the position of the light source, which is why during different times of the day, our shadows are of different sizes. Now, this is quite interesting because wherever our light source is, it changes the shape of our shadow as well. So if your light source, for example, the sun, it's in a different location than when it was before, your shadow is going to be different. So you don't need to go into the details of this, but you just need to understand that your light source, it dictates, or it's responsible for how your shadow is formed. All right. Now let's move on. Before we go into our further discussions, let's talk about how shadows are formed and how the rainbow is actually formed. If you look here, I have some quick questions for you. Now, do you remember the colors of the rainbow? Make a quick note of all the colors that you remember. Number two, where does the rainbow come from and how was it formed? Now, I want you to pause the video for a second and remember the questions inside of your head. And you must have studied this in class 4. So if you do remember, make a quick note of it, and then later you can see if your answers relate to mine. All right? Now, let's move on towards the answers. Um, if you look here, class, you can see that I've made a prism here in this image. It's quite similar to the one that's inside of your book. So if you have your book in front of you, open in front of you at the moment, you can see that there is a prism image on your book as well. Now, class, look here. You can see that a portion of white light, or like a beam of white light, is traveling into this prism or this light or this figure that is made out of glass, and it's coming out in the form of a rainbow. Now, everyone, light is actually made out of white light is actually made out of all the colors of the rainbow. So white light is actually carrying all the colors of the rainbow, and that's important for you to remember. What happens is that whenever light travels from one medium, for example, this medium air, into another medium, like over here, this is a solid object, glass, it changes its direction. Okay, its direction is changed in a way that it becomes bent. So if light was traveling in a straight line, when it moves from air to solid, it will bend itself, and then as it bends, it is distributed into different colors. This bending of light, class, the phenomena in which when light moves from one medium, and we've studied mediums before, I hope you remember, the three mediums are air, gas, sorry, air and gas are the same thing: air, solid, and liquid. So whenever light moves from one medium, for example, let's say an for example, let's say air, which is gas, into another medium, which is light, and is like a solid, it always bends its direction. So this bending of light is known as refraction. And refraction is an important phenomena that you all will need to remember. Now, look here, class, I've displayed a rainbow over here, and it's a very pretty rainbow. So how do rainbows exactly form? Rainbows are formed when, after the rain, some droplets of water, they're left inside of the air. So if you can see, if you can imagine simply, after rain, there are some droplets of water that are being left in the air, and they haven't yet fallen onto the earth. So what happens is, children, that light, it is being reflected from the air into these droplets of water, and all of these droplets of since there are droplets of water suspended in the air, they form a rainbow. And what happens is that light, it's being refracted from the air, which is another medium, gas, and it is being refracted into water, which is the droplets that are suspended. Whenever light is refracted, just like in the image of the prism we can see over here, a white light is being distributed into the different colors of the rainbow. And that's why over here, all of these droplets are suspended, and we are able to see the rainbow that we're experiencing over here. And that's exactly how a rainbow is formed. Now let's do a quick review of the concepts that we've studied in the slide over here. Now, the answers are white light is made out of all colors of light. As we've just discussed here, if you can see, white light is being refracted and it's becoming all the colors of the rainbow. Now, when light is traveling in a straight line, it appears to be white. Always remember this: light, when it travels in a straight line, it is of white color. But when it passes through a medium, liquid, solid, or gas, it changes its direction. Just like over here, we had. I'm going over this again and again because this is an important concept that you need to know. So when light travels through air, it's actually in the form of white light. But when it is refracted into another medium, it becomes a different color. As you can see over here, it is displayed in different colors right over here. Now, this property of changing its direction or shifting or bending a bit is called refraction. So, when light moves from one medium to another, it changes its direction and sometimes splits into the colors of the rainbow. And once it stops raining, light is refracted on some raindrops and we can see rainbows. So, this was an important discussion that we had. Now, class, for our first lecture to review, what have we studied? We've studied that refraction is the bending of light as it moves from one medium like air to another medium like water or a solid itself. Light is a form of energy, like we discussed before. Light, it carries photons. Let's go over the image once more so none of you forget. It carries photons, and these photons are actually carrying energy. And this energy carrying property of light, it helps the earth grow, and it helps you carry out your daily processes, because after all, the energy that is coming to us is in the form of light from the sun, and sun is the main source of energy for all living things on the earth. And light travels in a straight line. We've studied this before. Look at this image. Light is traveling in a straight line. Let's look at this image again. This one. Light is traveling in a straight line over here as well, and we've observed this many times, so it's a common phenomena that we all know about. And the last thing that we've studied is that light, it helps in the formation of shadows, and we've studied shadows as well. We know how they're formed. We know that light travels in a straight line, and when it hits an opaque object, shadows are formed in this way, and you must have seen shadows yourself as well. Now, class, this was all for lecture number one. Before you begin lecture number two, I'd like you to have a reading of the first three pages of the chapter. And after that, in the next lecture, we will be studying a pinhole camera and how pinhole cameras use or build upon the concept of light, and how cameras itself have been built. And it's a really interesting story that we'll be going into the details of how we've been able to capture images of people using the concept of light. And we'll study how the cameras were made and how cameras impact our daily life, and how these cameras build upon these very concepts that we studied over here. So we're going to be using everything that we our basic structure of light, our basic understanding of light, and we'll be using it, and we'll be working on it, but to understand a pinhole camera. So that's it for this lecture, everyone.